All right, in this section we're going to be working with formulas. And there are basically two learning outcomes here, that you can plug a value into a formula and evaluate it. It's easier of the two, I think. And the second one is that you can solve a basic formula for a specified variable. So let's look at the plugging a value in first. So we saw some of these in class. The perimeter of a rectangle is given by 2L plus 2W. Find the perimeter of a rectangle whose length is 20 feet and the width is 30 feet. If it's possible, I usually try to draw out these little figures to make sure I understand exactly what's going on. So we can call this side the length, this side the width. Does this formula make sense? The width, that's the length. And so the perimeter is the sum of all those, right? So we have one length plus another length plus one width plus another width, and that's where we get the 2L plus 2W. Okay? So we're given a length of 20. So I'll sometimes over here to the side write L equals 20 feet and W equals 30 feet. So if you knew nothing else on how to solve this problem, I recommend writing down all the given information. It's sort of a mathese, right? So you extract the formula out. They don't always give it to you. This is a shape where you should probably be able to figure that one out without them giving it to you. And then we're given a length of 20 feet and the width of 30 feet. Once you begin to write stuff out, sometimes you start making some connections. Okay, so I'm trying to find the perimeter. If I know the length, and I know the length here is 20, so 2 times 20 feet plus 2 times the width of 30 feet. Now we can multiply. 2 times 20 using order of operations is 40 feet plus 2 times 30 is 60 feet. And we can add 40 and 60 and get 100 feet. And after we work these application problems, it's always a good idea to look to see to make sure this makes sense. From a rectangle at 20 feet and 30 feet, yeah, that kind of makes sense. Example 2. Area of a circle is given by the formula area equals pi r squared. Find the area of a circle whose radius is 10 inches. So often, if they don't give you a figure, I can draw it out. So there's my circle. And I'm given an r of 10. And I'm given the formula of pi r squared. Now pi will be approximately equal to 3.14. Your calculator will have this button on there, so I recommend just using that. So area equals, the area is going to be pi times r squared. R in this case is 10, so I'll say 10 squared. And it's actually 10 inches. Let me pencil in inches here. So 10 inches squared is 100. We usually write that number first. So 100 pi inches squared. And this is a perfectly acceptable answer. This is the exact answer. So if I wanted to find the approximation, I would just put in 100 times, here's my pi button, press second in the little caret, and press enter. And we get, so the approximate answer would be 314, we'll say 0.16, if they tell us to round to the nearest hundredth or something like that. Okay, let me pull this calculator down. Okay, the surface area of a cylinder is given by 2 pi r squared plus 2 pi r h. Now this is one that I would not have you memorize. I wanted to have the shape here so you can see what a sort of a right circular cylinder looks like. So we want to find the surface area of the cylinder with a radius of 3 and a height of 7 inches. Okay, so again I'm going to write my formula down. 2 pi r squared plus 2 pi r h. Okay, and then we're given r is 3, so my figure there's 3, and the height is 7. So I think I'm given everything. We have a formula, find the area if I know the radius and I know its height. So plug in the radius, 2 pi times 3 squared plus 2 pi times 3 times 7. And I need to be putting my little inches in here. And so 3 squared is 9, and then 9 times 2 is 18. So here I have 18 pi inches squared plus 3 times 7 is 21 plus 2 is 42 pi inches squared. And then 18 plus 42 is going to be 60 pi inches squared. Now one quick note here, as we noted on the last one, is that my units are going to be in square units. This is always going to happen when we're talking about area. So when we're talking about length, like perimeter, we will have just regular units in general. And then with area, we have square units. And if you have a volume problem, it will be cubic units. And if I wanted to get an approximation for that, let's show you one more. We just press 60 pi. And remember, it's the inches that are square. We don't square the pi or square the 60. It's just the units here that are squared. And we get about 188.5. Okay. Solving for the unknown variable. Okay, so let's look at the methodology here. So the one on the left, we've done quite a bit. If I wanted to solve for x, for 2x equals 10, what would I do? So the question we ask is, how is that 2 connected to the x? It's multiplied, so I undo multiplication by division. So I'd cancel those out. And then I could simplify 10 over 2 to get 5. The same thing goes when we have letters here rather than numbers. Here we have many more letters than we have numbers. In this case, we don't have any numbers. We're trying to solve for b. Okay, very similar. And here, I was trying to solve for x. My methodology does not change a bit. So what is over here that I don't want over here is an a. How do I remove the a? I divide it, because the a is connected to the b through multiplication. So I undo multiplication with division. Those cancel, and I'm just left with b equals g over a. Now in this video, I'm pretty much just going to show you the sort of mechanics of doing it, and in class we'll see some applications on why we would want to do this. One little note here, with the problem on the left, x equals 10 over 2, we can simplify that. Those are two numbers that simplify pretty easily to get 5. But notice we can't divide g and a. We just leave it as g over a. And so I've got some steps there for you to clear fractions if needed, get all your terms, the letter you're solving for on the same side, and then move everything else to the other side, combine like terms if necessary, and then multiply or divide to solve for the variable. I would not recommend remembering those steps. I just wanted to pencil them in there for you in case you needed something to kind of go by. You'll get better at these by doing a handful of them. So pause the video on each one of these and see if you can solve for the letter indicated. All right, welcome back. AB equals C, solve for A. So let me go and put a little box around my A. How do I solve for A? I've got to move that B to the other side. Similar to the last problem, I'm going to divide both sides by B. So A equals C over B. And that is just the final answer. I know that sometimes seems unsatisfying, yet there it is. Okay, A plus B equals C, solve for A. So now I just usually put a box around the one I'm for, particularly in the beginning. You don't have to do that. How is this B connected to the A? Through addition. We undo addition through subtraction. So I'm going to subtract B from both sides. So A equals C minus B. Okay, that's exactly the same thing we'd do if I had something like this. X plus 2 equals 7. What would I do to get rid of this 2? I would subtract 2 from both sides. And I get x equals 7 minus 2. Exactly the same as we get here. The only difference is I can actually combine 7 minus 2. So in one sense, if you look at it this way, these can actually be thought of as being a little bit easier. We often cannot combine any terms over here. Again, pause the video here, see if you can do this one. If nothing else, I'll do the one on the left and pause it and see if you can do the one on the right. So AB plus C equals D. Solve for A. So let me put a little box around the A. I have two things here to get rid of. Doesn't really matter which way you do it, but as we looked in an earlier lesson, it's easier to take care of the addition subtraction first. So I'm going to subtract c from both sides. So I have a, b equals, those cancel out, d minus c. All right, one more step. Solving for a, I've got a b over here. I remove the b by division because it's tied to the a through multiplication. So a equals d minus c over b. Let's make that minus a little more pronounced. Okay, pause the video here. See if you can do this one on the right-hand side. Welcome back. Solving for c this time. Little box around there. What do I have to move over? I have this ab. It's all one term, so I can just move it over in one swoop. I'm going to subtract ab from both sides. So I'll have c equals d minus ab. And that's it. We solved for c. A little bit easier than the last one. The last one was 2 steps. Example 6. Solve for d. I've got a d here. Now I've got a couple different terms to move over, or pieces to move over. Let's move over this ab first. I could move over the c first, but I divide by c and end up with fractions really early on. I don't want to do that if I don't have to. So I'm going to subtract ab from both sides. Whoop. Those cancel, and I'm left with cd equals, bring down your e, minus ab. One more step. We're solving for d, right? How do I solve for d? I've got to move the c. The c is connected to d through multiplication. I undo multiplication with division. So d equals e minus ab all over c. Now we got a fraction, but we don't let that fraction worry us, right? We have solved for b. A equals b plus c all over 3. It's best to clear fractions so I can make these, the b and the c, more mobile. I can't really move them yet because I've got to do division here. I can't add the b and the c, and then I got division. So I undo division by multiplication. 3's cancel. I'm left with 3a equals b plus c. I'm solving for b, so if I put a little box around my b, it becomes a little more clear, maybe, which one to do. I'm going to work with the c. So I'm going to subtract c from both sides. Why subtract? Because I'm adding c. Opposite of addition is subtraction. So I have 3a minus c equals b. Now I usually write the letter I'm solving for on the left. You don't have to, it just looks a little bit better. So b equals 3a minus c. I would not count off for the first one at all. Both those are fine. Pause the video here, see if you can do this one. All right, welcome back. Solving for c. Put a little box around the c. Before I can begin moving these guys, I've got to divide through by 4. Sorry, I'm dividing through by 4, so I undo division with multiplication. 4's cancel out. So I have 4a equals b minus 3c. I'm solving for c. Okay, so I have a b over here I need to get rid of, and a minus 3. It's easier to take care of the addition subtraction first. So I'm going to subtract b from both sides. So I have 4a minus b equals, and just bring down your negative 3c. All right, one step away. To solve for c, I've got to move this minus 3, and it's connected through multiplication. I undo multiplication with, you got it, division. So let me put the answer up here. Let's cancel. So I have c equals 4a minus b all over a negative 3. Now this answer is perfectly fine in my book. often we don't like negatives just on the bottom, just sitting here when I can push it up top. So would you freak out if I did that and just move that negative up top? Remember when we just had a normal fraction like 1 over negative 2, and I said normally we write that negative up top, so that would be equal to negative 1/2. That's all I'm doing here. I'm going to move that negative out here. Now, depending on what's going on, this is a perfectly fine answer. We may want to go and distribute that negative through, and that would give me negative 4a plus b over 3. That's a perfectly fine answer. We often don't like to see that first term being negative if it doesn't hurt me to switch it around. All of these are perfectly acceptable answers. Each sort of look a little different and maybe more preferable. I'm okay with any one of them. Okay, a couple more. Solve for y. So ax plus by equals c. And we'll see some of these in a later lesson. So here I'm trying to solve here for y. So again, I have two terms over here, or one term over here, then one little part of a term to move. So I'm going to subtract ax. So by equals c minus ax. One more step. Good. Divide by b. B's canceled. So y equals c minus ax all over b. Okay, see if you can do this one on your own. You may feel a little more comfortable with this one because it has some numbers in it, but we do have more than just one variable. All right, welcome back. Solve for x. Put a little box around the one I'm solving for. So I've got to move this 2y over. It's being subtracted, so I'll add 2y to both sides. So I have 3x equals 9 plus 2y. And one more step, divide through by 3. So x equals 9 plus 2y divided by 3. Now there's another way we can write this one, is that I can divide 3 into both of these terms here. So I can say x equals 9 thirds plus 2 thirds y, and I can simplify that 9 thirds. It's 3 plus 2 thirds y. So both of these are certainly acceptable answers.